This video will demonstrate how to calculate hip and ascending jack rafters using a Construction Master Pro calculator. We will calculate theoretical and overall rafter lengths for Unit 3, Lab 1. Lab 1 uses the following designs and spans. The pitch is an 8/12 pitch, or an 8-inch pitch. This simply means that for every 12 inches of travel in the run direction, the roof slopes up 8 inches in the rise dimension. The span is 48 inches. Remember, span is the overall width of the building. For our calculations, we will need to provide the calculator with run dimensions. Therefore, we will need to divide the span by 2 to find the run. The rafter on-center spacing is 16 inches. We will need to set the proper preferences in our calculator for this before we can calculate our jack rafters. The jack layout is what we call ascending. This just means that we lay out our jack rafters starting from the outside corner of the building and mark each layout location working away from the corner, and as a result, each jack becomes longer than the previous. As we set the jack rafters, they ascend up from the bottom of the hip until we reach the ridge. Once we reach the ridge, the rafters are no longer called jacks, but rather common rafters. You can think of a jack rafter as just a common rafter that is cut short by the hip rafter. We will lay out all of our rafters with a 2.5-inch height above plate. I will show you how to do this when we lay out the rafters in the next video. The overhang of this slab is 2 inches. We will need to calculate the overall length of our hip and jack rafters to allow for this overhang. So the first thing I'm going to do is I'm going to type in my pitch of my roof. So 8-inch pitch specifies the proper roof slope, roof pitch. Now I'm going to calculate my hip rafter by typing in my span. And remember, the span is the overall width of the building, 48 inches. But when I type in my hip rafter calculations, I need to give the calculator the run dimension. So remember, the run is half of the span. So I'm going to divide my span by 2 to get my run. So I'm going to type in my run button up there to indicate to the calculator that that is my run that I'm going to calculate. And previously we've calculated common rafters, and to find the theoretical length of a common rafter you would press the diagonal button here. For a hip rafter we simply press the hip/V button. That button calculates the theoretical length of hip and valley rafters for a given run. So our run is at 24 inches. We hit the hip valley button and we get a hip theoretical length of 37.5 inches. And that is a theoretical. We can also calculate the overall length of the hip rafter by including the overhang amount, which in this case is 2 inches, to our run dimension and then recalculating the hip length. So I'm going to take my run, 24 inches, and then I'm going to add my overhang, 2 inches. So I have a new effective run, which is from the center of the ridge to the tail of my hip rafter, is now 26 inches, and I'll hit the run button. So I've got a new run, and now I can hit the hip valley button again to get my overall hip length, 40 5/8 inches overall. So for my hip rafter, I have my theoretical length, 37.5 inches, and I have my overall length of 40 5/8 inches. The pitch I'm going to use is 8/12. If we refer to our plan drawings, we see here the end of a hip roof. I've indicated the overall span as well as the run, which is half of the span, and the on-center spacing of the rafters, which is 16 inches on center. The rafters are laid out in an ascending fashion, meaning they start at 0 from the outside corner of the building and they increase up the length of the building. If we move along the lower line by our on-center spacing of 16 inches, you can see the first jack rafter, which is the vertical line on our drawing, extending from the wall plate up to the hip rafter. The next jack will be at an additional 16 inches beyond the first jack, or 16 plus 16 equals 32. So at the 32-inch mark on our wall plate, we'll have our second jack. We will continue moving the layout of each subsequent jack rafter by the on-center spacing, in this case 16 inches, until we have reached the layout position of the ridge. The ridge position may or may not be on an on-center spacing increment. It will be at the layout position of the run, however. Notice that the ridge is at a 45-degree angle to the wall plates. Can you see the square box that defines each jack location? Can you also see that once we reach the ridge, we have a perfectly square box with the leg of each square that is the length of the run? This is a constant and will be true for all roofs where the pitch is the same on all sides of the roof and where the wall corners form a 90-degree angle. The layout position of the ridge will always be equal to the run of the roof. So we're now ready to calculate the jack rafters. The first thing we need to do when we're getting ready to calculate the jack rafters is to set the preferences of our calculator according to our desired settings. In this case, we want our jacks to calculate in an ascending fashion, meaning they start from the outside corner of the wall plate and they work their way up the hip rafter. We call that ascending. So we'll start with the smallest, increase each jack rafter in length as we go up. The way we tell our calculator to set to ascending jacks, and this is only true for the Construction Master Pro. You can't do this with the Construction Master 5. Only the Pro version has this option. If you go into the Convert and then Store, okay, that's the Preferences section of the calculator. The first thing that we see comes up says frac, okay, that's fractions of an inch, and that's accuracy. My calculator is set to 1/16 of an inch of accuracy, which is adequate for what we're doing now. I'm going to continue to hit the Store button until I see the setting for jack, and it'll say either ascend or descend. Ascend is what I want, so I'm going to leave that as it is. If it says descend, you can press the plus or minus button to change that option. So I have it set to jack ascend, and that's what I want, is ascending jacks, and so now I can clear my calculator. The other thing I want to make sure is that my on-center spacing is accurately set. To set our on-center spacing, we type in whatever our desired on-center spacing is, in this case 16 inches. So I'll type in 16 inch. And then I'm going to hit the Store 5 button. And when we do that, we should see an OC stored 16 inch. That ensures that our jack rafters will calculate based on a 16 inch on-center spacing. So now to calculate my jack rafters, I'll just double check and make sure that my pitch is properly set, 8-inch pitch. I can type in my run. In this case, it's a 24-inch run. And if I hit the jack button, I'll see a jack OC stored. That tells me that the calculator is calculating based on a 16-inch on-center spacing, which is correct. That's what we want. I'm going to hit the jack button again, and it's going to tell me INCR. INCR is an abbreviation for increment, and in this case we can see that our jack length is 19¼ inches from one jack to the next. So every jack going uphill will be 19¼ inches longer than the previous one. If I hit the jack button again, I get my jack 1. You'll notice that it is our same as our increment, 19¼ inches. That's because we're starting at 0, or the very outside corner of the wall, and working our way up. So our first jack, jack 1, equals 19¼ inches, and that is a theoretical length. If we want to calculate the overall length of the jack rafter, we can simply calculate the diagonal dimension of a tail of a single rafter, or a common rafter. If you recall, our overhang is 2 inches. So I'm going to type in 2-inch run and find the diagonal for a 2-inch run. So the diagonal for my overhang is 2 3/8 inches. So plus 2 3/8 inches for the tail. Okay, that's just the tail, and I can add that to my theoretical jack length. So 19¼ inch. So my overall length of jack 1 is 21 5/8 inches.